Uh, Hello everyone. So this welcome to second. So myself Annu and I am PhD scholar at IIT Hyderabad. So what is my aim is like there are two live sessions directly running simultaneously. Okay, so one is taken by other PMRF fellow and the second is taken by me. So we have to make sure that whatever doubts you are facing in a particular week, we will clear your doubts in these weeks in the live session, and we will solve some of the problems. So first of all, I will just go through the content of the course, the content of the second week especially. So first week we saw how to solve the proper problems, and we also saw the Python codes associated with it. So let's go to the just topics. So first, it started with basics of continuous and discrete time systems. So in what sense we say it is a continuous time, and in what sense we say this is a discrete time? So do you think that uh, all the signals are continuous, or do you think that is it a discrete, how we discretize and how we characterize it? So continuous time means if we are defining it for the all the time, then it is a continuous time, and if we are defining it with respect to some discrete values, so it is a discrete time. So this is a discrete time, dn, and we name it with respect to n, and this is here we name it with respect to t. So what is the difference is here we cannot get the discrete values, but rather we have to get it the difference between particular values and the difference between these values. So like this, one of the contrast time. So if you ask all the physically occurring signals are what kind? It's analog in nature. Okay. So whatever we are speaking, we are sensing, that is analog signals. Now you may wonder, analog signals are always continuous time or discrete time? Tell me. So since only two students have joined, so the analog signals can be continuous and can be discrete. I would like to ask you one question. So here I'm telling you the analog signals can be continuous, can be discrete. Okay. Now, sorry. I would like to ask you one question. What is digital signal in that case? What is digital signal? You told me that what is continuous signal and what is discrete signal. And I'm telling you all the naturally or physically occurring signals are analog in nature. Okay. And they can be continuous and discrete. Okay. And we have characterized it. So in digital signal, what extra things that you are adding? What is the difference between digital signal and discrete signal? So if we quantize in time, that is getting discrete, as well as quantize in amplitude, that will give you, this whole thing will give you digital signal. Okay, so if you say analog signal can be continuous, can be discrete, but if we quantize or if we discretized in amplitude as well as in time, then it is a digital signal. Okay, then it is a digital signal. So that is the difference. Okay, simple, it is defined for all t, it is defined only at discrete time intervals. Okay, that we already know. Now, what are the mathematical representation? So basically, we represent it with respect to n and here with respect to t. Okay, we will see some of the Python codes also, how discrete and continuous time looks like. Okay, so I'm just showing you my screen just to have the understanding. Okay, so I think you can see my screen. Can you see my screen? Can anyone? Confirm.
No, ma'am, your screen is not visible.
अच्छा अच्छा एक सेकेंड. Okay, so I think it's visible. It's sharing. So yes. So these are the simple Python code for simulating and demonstrating basics of signal systems. Okay. So if we import numpy as NP, that is for the array, okay, and matplotlib.pyplot for as PLT, that is for the plotting. And I'm using this library skypy.signal, that is import convol. So I'm signals with uh, how many 0 to 10, and this is 1000 uh, samples I'm taking. That is in lens space. And time from 0 to 10. And I'm keeping continuous time as np.sign, that is the library from the numpy, then 2 pi omega t. So that is omega, that is the frequency that I'm keeping. And here also this different frequency I'm keeping. And here if you say this is n I'm keeping. So t, if you can say, this is at the interval of 0.1, whereas it is just 1000 samples you are keeping from 0 to 100, 10. Whereas here it is a 0.1. So if we calculate, print calculations are there, printf continuous signal, then discrete time signals are also there. We will show that we can have in the output window. So let's see the plot. See, so this is what. So this particular, that is a continuous time signal. It's a blue color, so that is overlapped with the red. And now this red color are discrete signal. So this is what the discrete signal. But if we quantize here also in the time, it is amplitude domain, because here you can see this is time, and here this is amplitude. So in continuous time, that length space is actually the continuous function itself in the numpy. So if you want to see the documentation, you can see that generates the continuous time signal. That's why the length space is for the continuous time signal, whereas we are taking particular samples out of it. So here it is a discrete time signal. So first, for 4 5 values also have printed, 10 values have printed. Now if you want to see the convolution, that is also one of the signal system basics. So first, if you have the rectangular signal, that we have defining it from this blue color, and if the convolution. So as of now, I wanted to show you what is discrete and continuous time signal. So okay, we will move ahead with some odd even function. So last class we saw what is a odd and what is a even function. So as we know, every signal or any signal can be represented as a sum of. So we will see that. So here also, we are determining this using length space. We have continuous time, and this is a discrete time. So again, that is the same. And if you want to demonstrate using two even and odd signals, so even and odd signal, the even part can be represented as xt plus x of minus t divided by 2. So this is colon is for all the samples, because we are taking as a samples. Okay, so we are taking all the samples starting from -1. So divided by, and this x or t is xt minus x of t minus 1. So with we are reversing the time, and then we are summing and we are subtracting and divided by 2. So if the original signal is cos t plus sin t, and first 10 values, if you see here, we will have the first 10 values we will see in the output window, and the odd part also we will see first 10 values, and then we will plot. So see how the plot looks like. So this is also one of the example of continuous time signal and discrete time signal. This is how it looks like. Okay, we have as blue color. Okay, but if you sum even part and the odd part, then you get this blue signal. Also, one thing, you see this even signal. So y-axis. Okay, symmetric around the y-axis. Okay, it is symmetric around the y-axis. Now you may wonder, I told you last class that the odd part should be symmetric around. So in normal signal system, we divide it to half. So this is color. You observe green color. Origin. So symmetric around origin. Symmetric around origin means here you can see here the values and the values are x odd of 0 is 0. See this. Some around this. The theory real real time graphs. Okay. Oh, nice. Now, what are the applications and examples? So, if you talk about applications, so electronics, you okay, signal processing. In this senses, we are using in digital signal processing, obviously, because we without in order to have the digital signal, we need to discrete. Okay, then we are feeding it to quantizer. That is and then finally we'll get to digital signal. So digital signal processing, we will usually see this digital signal. Okay. Whereas, for example, representing speech signals as continuous and sample data. So sampling, this discrete can also be represented as sample. So if we are taking the sample and whole circuit. So suppose one sample, two sample, this values will come from the even and odd and periodic signals. So as we know, even this and odd signals are satisfying this, xt is equals to x of minus t, whereas xt is equals to x of minus t. Okay, so what it actually says this, for example, you have one signal xt. Now you want to find it xe of t, what is that? And xo of t, what is that? So xe of t is represented as 1 by 2 xt plus x of minus t, whereas xo of t is represented as 1 by 2 xt minus x of minus t. Okay, so any signal can be represented in these two parts. Okay, whereas periodic signals have particular property that it repeats after some fundamental period. And there's often questions about this. Find the fundamental frequency of particular function. So that will also come in gate. So this is part of this even and odd signal, and we already saw this periodic signal that we will see. So also you can derive, that is not a problem. How will you derive for even and this property for odd? That's why it states that this odd is xt plus x of minus t is equals to 0. That's why we saw this if it is false signal equals to 0 because it is negative. So origin is always 0. Okay. You need to determine whether the signal is even or odd. So if xt is t square, you need to calculate x of minus t, that is minus t square, it is t square only, and it is equal. So this is the even signal. Similarly, you can compute for the odd signal. Okay. And periodic signal, if you see, we'll have later. Okay, orthogonality. So if you see orthogonality, so what is orthogonal signal? So if you have two signals, xt and yt, and now we need to determine whether they are orthogonal to each other or not, then we need to have this. particular formula. If this is integrating over all the time period xt, multiplication with yt is 0, then dt 0, then we are saying orthogonal signal. So what is the real-time implication of orthogonal signal? Why we see that orthogonal signal? So you may wonder whether sine and cosine are orthogonal or not. So answer is yes. Let us prove that. So minus infinity to infinity, sine t cos t dt. Now you have this formula. What is that? Sine t plus t by 2. This is 1 by 2. It will so cos 0. And this is cos 0 is 1, 1 by 2, sine t dt. And the area under sine is 0. Okay, so answer is 0. So this means sine t cos t are orthogonal to each other. Okay, now one another way to find the orthogonal is inner product. Because signal can be represented in terms of either vector or continuous time signal. So if we say vector, that is a particular values, then we name it as a discrete signal. So in that case, if suppose v1 and v2 are two vectors, then if v1 transpose v2 is 0, means they are orthogonal, then they are orthogonal. So in other words, what we see is, so vi, and if you say what is the formula of inner product, so v1 t v2, okay, this is the inner product. It is equals to v1 v2 summation of vi vj, I range from 1 to n, I or j range from 1 to n, where n is length of v1. Okay, sum of their individual multiplication, their indices individual multiplication should be 0. In that way, these are orthogonal. So orthogonality, you may wonder where it is used. So it is used in signal decomposition. Okay, and also basis function in Fourier series are orthogonal. So we need to make sure the basics that we are representing, or as a Cartesian coordinates, or also some of the eigenvalue vector decomposition, they should be orthogonal to each other, so that using that vectors we can easily represent other signals or other vectors. Because if you have suppose v1 and v2 as orthogonal vector, so using this means their linear combination will also be lying in this plane. So that is also used to have this orthogonality. We find this orthogonal vectors so that their linear combination will lie in that plane only. And using that vector, you can find the other vectors that lie in that plane. So this is one of the application of the inner product. And inner product, if they are 0, then we say that is orthogonal to each other. And one of the other thing is correlation. So we also calculate the correlation of two signals using inner product. So if we say, suppose this is a signal 1 and this is a signal 2, and if we calculate inner product of these two signals, and if it is greater, inner product means here correlation, and if it is greater or high, then we call it highly correlated. So correlation is used to find the similarity between two signals. So this is used to find similarity, or inner product is used to find the similarity. And whereas if you say convolution, convolution is used LTI system. Okay. So prove that sine n pi t and cos n pi t are orthogonal. We already proved. Okay. We can prove anyway. Minus infinity to infinity sine n pi t cos n pi t dt should be equal to 0. Okay. And basic formula you should know. 2 sine xt cos xt is equals to what? Sine y by, let's say, just simple 2 cos x. Okay. This is sine x plus y by 2 plus cos x minus y by 2. Okay. You can tally with the internet also, but yeah, this is the formula. And if it is 2 cos x, then after formulas. That is the other way around. From So 2 sine x plus y by 2 cos x minus y by 2, then you just sine. And if it is cos by 2, x minus sine y. So you have to calculate in this way. So you can prove it that this is 0. And if it is a right shift, if we are doing the right shift, it is delayed. And if we are doing a left shift, then it is advanced. So left shift and right shift, if we say, let's say simple example, xt, that is a proposed. Let's say you want to do xt minus 1, and this is 1. How will you do? I will tell you the trick that you will never forget. How will you do? How the signal will look like. So whenever this negative sign is there, you have to do the opposite in the time domain. So you have to do t plus 1 in the time domain in the signal. So you do 0, here t plus 1 is there, 1. So 0 will look like here 1. 1 will go to 2. So this. So this is 0.5. So 0.5, this is 1.5. So that's why this is t minus 1. That is a right shift. That's why this t minus 1, it is shifting to right. It is delay. Whereas left, it is advanced. So if you want to do t plus 1, how will it like? Trick is you need to do the opposite. It is plus 1, so you need to minus it in the time domain. So 0 will go to minus 1. 0.5 will go to minus 0.5. Where 1 minus 1 will go to 0. Okay. So 0 here, this is here, this is here. So this is t plus 1, and it is going to left shift. Okay. And similarly, if you want to do compression and decompression, suppose this is x80. What if x is greater than 1, then you call it a compression. And if it is x less than 1, then you call it decompression. Okay, let's solve some problems related to this. It's very, very interesting. And we always confuse how will it look like. Suppose you have xt. Now tell me how compression will look like. Compression, I told, if A is 3 and it is greater than 1, so it will be compression. And suppose this is 3, this is minus 3, this is 3. So what I told is, if it is multiplied, so you have to divide it in the real time. So 3 by 3, 1. 3 minus 3, this is minus 1. The actual signal was minus 3. Whereas this color is xt. Nice. Now if you want to decompress it, suppose A is equals to 1 by 3, suppose. Okay. Since A is less than 1, so it is a decompression. Now tell me how it looks like. X of 1 by 3. So since it is a divide, so you have to actually multiply it. So 3, 3, 9. This is minus 9. So it will look like this. Nice. Minus 3, 3. Whereas red color is minus 1. Okay. So red is X of 3t, which is compression. Purple is X of 1 by 3. Expansion, sorry, decompression is not an expansion. Or a different word for decompression. Sorry if I confuse. X of t. Original signal. Okay. So far, so good. So what is the trick is, if you have A somewhere, okay? So if it is multiplication, you have to do real time pay, time you have to do divide by A. Okay. And if it is T by A, in time pay, you have to multiply by A. Similarly, if it is in T plus 3, so you have to do plus in the signal. Similarly, if it is T plus 3, you have to do in the signal T minus 3, like we did here. Okay, you are just shifting it to here. So the signal will look like. So it is delayed. Since it is getting, wherever it is, what it was starting at 1, now it is starting at 2. You see like this. Wherever it was starting at 0, now it is starting at 1. So it is a delay actually, right? You're delaying your time. So train was supposed to come at 0 time, but it came at 1. So it is actually delaying. So that's why it is getting aage in the right shift. Whereas advance, so train was supposed to come at 0, but it came at minus 1 only. So it is advance. Okay. So this is time. So that's why it is looking like that. So t minus 1, it is delayed, but how it is going to right, whereas it's going to left. Okay. Similarly, this is for the compression decompression. Now let's solve some problem that involves both compression decompression as decompression, sorry, expansion as well as delayed advance version. So how will we solve that? So gate question, in that gate question, 1 or 2 question definitely will come. So suppose one question is there. You have x 3t plus 4. How will you solve? And the x is, for the sake of simplicity, I'm taking it. Hmm. How will this look like? So here, in order to solve this problem, you have to first figure it out whether you want to delay the things, advance the things, and whether you want to first compress or decompress. So the best way to do is, for the sake of simplicity, okay? So now how can you do? This is equal to x3t plus 6, is it? Now, if you see this particular, first you need to do the advance. So let's first do the advance. So x t plus 2. Okay. How will it look like? So what you have to do? Minus it here. So 4 minus 6, 1 minus 8. 2 seconds. Hmm? This is x t plus 2. Now you need to give this 3. Okay. So x 3t plus 2 is what? T. So 3, you have to divide by 4 by 3 minus 8 by 3. So this is how the signal will look like. X 3t plus 6. Okay, this is the first way that we usually follow, or that is a best way also. The second way is, what was the question? The question was 3t plus 6. So first you would like to advance it. Let's see. So how will you do? So you have the signal as 6 minus 6 x3. Okay, you want to first keep it here. How will you do? So this 6 will go, 6 minus 6 is 0, minus 12. Xt plus 6. Okay. Now, since if you do t 3 here, suppose if you want to keep, now you want to expand, sorry, decompress it. Okay, compress it. So how will you do? Suppose you, if you do 3 t, so it will come 18, right? Because now it is xt plus 6. So this is the wrong way. You cannot do this. Okay, you cannot do like this. If you want to do first this plus sign also, you need to make sure it follows with the compression. So x3 t plus 2. So first if you'd like to have the compression. So if you, this can be here. So 3, 2 minus 2. X 3t. Yeah. Now if you want to add it to, so This is 0, this is -4. Actually, I think this is not time, but yeah, this is the way to solve. So it should match. I'm seeing where I'm doing wrong. X3 t plus 2 x3 divided by 3 minus 2 minus 4. Okay. And 4. Okay, we'll get back to this. But yeah, this is the way. You can either go this way or this way, but you have to make sure that this is not changing the expression here. So x3 t plus 2, suppose is this one. So you cannot do this way because you are first compressing it. First, you need to make sure this way. It always goes like this. So t minus 2, sorry, t plus 2, then you are doing the compression. So you cannot do first 3. Okay, so that's this way. So the first way is only correct. And we can tally with other signal also with the help of code. So I have done that. You can see that way also. So suppose you need to calculate xt is equals to e power minus 3. If you want to calculate x3 t minus 3, how will it look like? Simply you can just keep xt is equals to x of t minus 3, and this is xt minus 3 into x of 3. So x of 3 minus 3. So scaling in compression time. So the compression is, as I told, if A is greater than 1, and if it is expansion, if A is less than 1. Okay, but should be greater than 0, obviously. And this is a scaled version. Example problem. There are some problems. We will see that in a real time also. So I will show you now. Sharing. So yes, you can see here. Suppose you have the signal, original signal x of t, that is blue color, and the shifted signal xt minus 5 is orange color, and this is scaled version 2t. Okay, so what exactly 5t xt minus 5 is showing you is the previous signal used to start at, suppose, let's see, 0. So 0, it is like here. This point you make sure. Then it will advance the signal, sorry, delay the signal by pi. So 1, 2, 3, 5. So it is starting from here. So minus 7.5 or the exact minus 5, it will start from there. Suppose 0.5 minus 5, it's here, but it should be 0 here. Or orange signal, you always see orange. So minus 5, 0. Similarly, scaled version x of 2t. So you are actually, what you're doing is compression because it is greater than 1. So this is a scaled version. So you can see the width, it's almost half, right? Sorry, compressed by half. Whatever the signal width was there for the blue color, it is half because it's in a sine. And we are checking the orthogonality. So sine t and cos t. So sine is blue color and this is a cos t. So what inner product says that you need to multiply it every indices. So here we are multiplying it. Suppose this is whatever value it's coming plus. whatever value is coming here, this indices, plus whatever value is coming here, this indices, plus all the indices. You are just multiplying the values and just summing it. Okay. So that value should be equal to 0. So inner product is actually e power 10 power minus 16. It is equal to 0 almost. 10, 16, 10, 10 power minus 16 into minus 1.67. So it is almost 0.00000016 power, and it is like this. So in practice in signal, you'll not get exact 0. That's my way of telling that you will not get exact 0, but almost equal to 0. So it is orthogonal to check, and it is orthogonal to each other. Similarly, one topic sir covered in the class is signal to noise ratio. What is signal and noise? So here you can see the actual signal is blue color, but the noise around it is this orange color. So this is how it looks like in real time. And same code, but simulate question number 1. So what was that? So it was a signal was sine omega. So simulate question number 1. The question number 1 was sine omega. Okay. So some questions which I'm solving, I'm simulating that also. We will, after solving only, we will see this question, this plots. Scaling effect on the signals. We'll see. So coming back to the theory, the analysis. Okay. So how will it look like? We can just replace it with the t by 2t and 0.5 t. So definition of signals and noise. So whatever the signal which is desired is a signal. And unwanted disturbance is actually a noise that we saw already. And mathematical representation is SNR is signal to noise ratio. What is the power of the signal and divided by the what is power that is there in this noise. So how will you calculate the power? Okay. So power is nothing but the amplitude sum, square of the amplitude sum. So if signal is this, you are squaring it. If signal is 9, what is the power? How will you calculate the power? Obviously, here also it will be there. You need to calculate sine square. So this is, and then you're summing it on the area. Sine square t 80 is the power contained in sine t dt. Sine t. Okay. So power is nothing but you're calculating. Obviously, since it is a periodic signal, so you're calculating over a period x t square dt. Okay. This is 1 by t. So power is limited because it is defined periodic signal. Whereas if you calculate the energy is for the uh, non-periodic signal, then it is integration minus infinity to infinity x of t square. Okay. So similarly, you need to calculate the power of desired signal divided by power of undesired signal. Now, since power energy concept came here, so my question is, power is always defined for . defined for periodic signal. And we saw periodic signal is infinite in duration. Agree? Because it's sine, cosine, all the periodic signal, and they are infinite in duration. Agree. Now, we always calculate power for those because it is we are divided by t, we are averaging it over one time period, and then we are squaring it, and when we are finding the integration over that or the area under that, and that is called a power. So my question is, what will be the power for energy signal, which is a non-periodic signal? So what will the power for energy signal or energy signal is what? Non-periodic signal. What will the power? Gaurav, any idea?
Yes, ma'am.
What will be the power for energy signal or non-periodic signal?
I don't know, ma'am.
Okay, no problem. Since power you are calculating over one period, since there is no period here, so it will be zero. Very commonly asked question. Power of non-periodic signal or the energy signal is zero. Power of energy signal or non-periodic signal is zero. Whereas energy of power signal or periodic signal is infinite because you are just summing it for an infinite duration from formula only. It will be infinite because it is infinite duration. So this is infinity. Okay. Now, for example, is this P signal is this P noise is this calculate SNR. So SNR is nothing but 100 watt divided by 10 watt. This is 10. Okay. So I will take some questions on periodic and non-periodic signals. So I think later I'll take. But yeah, now one of the class was on type of physical signal. So electrical signals is actually voltage current, that is a physical signal, physically a signal. Then mechanical signal is force, voltage, force and velocity. Whereas biological signal is EEG and ECG. So these are the naturally occurring signals. So electrical voltage current, mechanical force and velocity, biological EE and ECG. Similarly, types, example of physical signals. So ECG waves in medical diagnostic, whereas audio signals in human speech processing. So how will you actually mathematically model it? So signals in physics are often represented as A sine omega t phi. So we are representing in terms of sinusoid. So you may wonder why we always represent the signal in the form of sinusoid, not in triangle, not in rectangle, and not in square waves. Why like that? Because sine has Fourier transform of impulse function. So if you have sine or cosine, obviously, sine, cosine, these two signals comes into the umbrella of sine. Okay, so sine, cosine have Fourier transform of impulse function. That is for the cosine a by 2 fc minus fc a by 2. This is sine, and if you say cosine, this is a by 2 fc minus a by 2 a by 2 fc. So in frequency domain, it takes only a single frequency or the single bandwidth. The bandwidth is takes in the frequency domain is very less. Okay, so that's why we represent every physically acting signal with the respect of sine cosine. In fact, if you see in the modulation, the crystal oscillator, we modulate with respect to sine or crystal oscillator generate frequency in the form of sine or cosine because it is having the frequency domain, is having the single frequency. But if you say simple, uh, rectangular wave in time domain, RT. What it is having in the frequency domain? It is having the frequency domain as sinc function. Practically, the bandwidth is infinity, which is not even feasible to store. And we do the spectrum analyzing in frequency domain. That's why we represent every physically accurate signal to sine and cosine, not in rectangular, triangular, or any other things. Okay, so this is bandwidth is frequency domain. Now you may ask me, we we are using pulse to do the modulation. Why we use pulse in that case to do modulation? We don't use pulse actually. We use raised cosine pulse. Okay, raised cosine pulse where it's almost zero. Okay, in time domain that has frequency domain as normal rectangle. So this if you do the filtering, okay, the low pass filter and high pass filter, the rectangular window filter, windowing if you do, so this will go. So leakage will go, power leakage will go. So if you remove the leakage and do the in frequency domain, so it is having the fixed bandwidth. So that's why analog pulse digital filter are done using this raised cosine pulse. It's not normal sinc pulse. It is a raised cosine pulse. So this is a raised cosine, and that is given fixed bandwidth. But normally accurate signal is represented of sine cosine. Now, the every signal is characterized by its first is amplitude and second is phase. Whereas the sine is same, omega is same, t is also same. So you are differentiating it with respect to phi and amplitude. Okay. Now this phi is controlled by the phase shifter. That we characterize in the antenna. That will give the directivity. Okay. And this amplitude is again another factor that is governed. Also, one of the main advantage of this particular signal, xt, a sine omega t plus phi, if you pass it to a LTI system, it will give output as a dash sine omega t plus phi dash. Means what I'm telling you, the sine cosine signal doesn't change its nature while passing it through to LTI system. Understood? So it is only changing the nature of amplitude and phi phase, whereas sine cosine doesn't change its nature. One of the main reason. Okay, I hope you can understand that. And the summary before moving to the questions. Continuous and discrete systems differ fundamentally. Okay. Even odd and periodic signals help in Fourier analysis that we will take care. Signal to noise ratio affects clarity. Shifting and scaling modify signals in time and frequency domains. Sensory perception is based on signal processing in brain. Well and good. We will see some of the problems related to periodic and aperiodic signal. That is very, very important. Just a second. Yeah, it's starting here. Now, if xt is equals to sine square 4 pi t, what will the period? Nishant. Hello, Dishant. Hello. Okay. So, in order to solve the problem of periodic and aperiodic, first of all, you need to know that which is periodic signal and which is not. Okay. So, periodic signal, if it is repeating and it is value same, then it is a periodic. Well and good. It is a periodic signal. Now, since all sine and cosine are periodic in nature, their sum is also periodic in nature. Okay. Their sum is also periodic in nature. Now we can represent in the sum of sine cosine. So let's first represent xt is equals to sine square 4 pi t. It is equals to 1 by 2, 1 minus cos 2 4 pi t. It is nothing but 1 by 2, 1 minus cos 8 pi t. I'm using the formula. So what does the formula says? Formula says that cos square x is equals to 2 sine square x is equals to 1 minus cos 2x. So this formula I'm using here and here. Okay. So now going back to xt representation. So xt we represented as 1 by 2 minus cos 8 by t. Okay, so as we know, cosine sine are periodic in nature. And if we sum two periodic signals, the resultant will be periodic signal only. But here you can see it is a sum of DC signal plus one periodic signal. So what does that mean? Is DC signal periodic? Is DC signal periodic? The answer is yes. All DC signals are periodic in nature. Okay, with a frequency of zero, or not zero. It is undefined. So sorry, period of a DC signal. DC signal. So T. So DC signal period is not undefined. It is undefined. So DC signal, well and good. Okay. Now second, that is a cos 2 8 pi t. This is a DC signal. All of you agree? This is a DC signal. Second is period signal. This is also periodic signal. Okay. So if we sum and if we multiply, if we do the operations over 2 or 3 periodic signal, the resultant will be periodic. So the answer is periodic for sure. Now question arises, what is a period? What is a period? So here T naught for this particular signal, this x1 t. Okay, period for this particular signal is period of x1 t is nothing but 2 pi by omega naught. This is omega naught. 2 pi by 8 pi. This is 1 by 4. Since it is not defined, so period of this particular signal is 1 by. So answer is 1 by 4. Done. So this is a very good question. It is often asked many times in the gate questions. And the best way to understand a periodic signal is it will repeat after some point, like sine. Obviously, period signal will also be infinite duration. So it's not a period signal. This is not period signal. If I say infinity, infinity, then it is a period signal, periodic signal. Now, well and good. We saw this is the periodic signal and the sum and the periodic signal is also similar. Now, my question is, suppose tell me whether xt is periodic signal or not. So before finding any period of any signal, we need to find it whether it is periodic. So yes, let's find T naught. This is T. This is T. Let's find T1 because it is individual sum. Since xt is sum of x1t plus x2t, where x1t is nothing but sine root by t, x2t is nothing but cos 2 pi t. So t1 is nothing but 2 pi by omega naught, that is root 2. And t2 is nothing but 2 pi by 2 pi, it is 1. So we need to find the ratio of that. So 2 pi by root 2 by 2 pi by 2 pi. So this is just 2 pi by root 2. We need to find whether t1 by t2 is rational or not. What do you say? Is it rational? Answer is irrational because root 2 is irrational. So particular signal xt is non-periodic in nature. Okay, now I'm giving you next question. So next question is this. Tell me whether it is periodic or not, and if it is periodic, what is the period of x? Give me a second, I will have water. Dishant, Gaurav, any idea?
Solving, ma'am.
Achha. Are you taking this course, Gaurav? Like, have you watched all the lectures of week 1, week 2?
I have watched complete lecture of week one, but not all the lectures of week two because I have joined little bit late.
Okay, 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 fine. So you are crediting this course.
Yeah, ma'am.
Okay, okay. No problem. So basically, we need to calculate the period. So first of all, we need to split into two particular functions. So
Ma'am,
as
it's
we know,
periodic.
very nice, periodic. So it is a periodic, very true. But in order to calculate a common period, we need to find one formula. We need to go through one formula. I'll tell you what. Now, since xt is sum of x1t plus x2t. So x1t is sine 6 by t. Shobhana, can you please mute yourself? Can you please mute yourself? So we need to calculate t1. So period for this x1 is 2 pi by 6 pi. This is nothing but let's keep 2 pi by 6 pi only. Now x2t has cos pi pi t. Now t2 is 2 pi by 5 pi. This is 2 by 6. This is 2 by 5. Now t1 by t2 is 2 by 6, 5 by 2. So 5 by 6. It is rational. So first problem is that period, period, periodic signal. Okay. Now we need to find the period. So the common period is nothing but LCM of T1, T2. So LCM of, what is that? 2 by 6, 2 by 5, 2 by 6, 2 by 5. It's nothing but LCM of 2 by 2, SCF of 6 by. So LCM of fractions x by y or a by b is equals to LCM of x by a divided by SCF of yb. Similarly, if you need to calculate HCF of x by y, a by b, it's nothing but HCF of xa, LCM of yb. So this is the formula that I'm trying to say, and we will use that only. Okay, now some simple for things on this LCM HCF is product of two numbers is nothing but SCF of two numbers into LCM of two numbers. Okay. Now, if you say what is SCF, SCF is highest common factor. And if you want to calculate any, suppose this is 3, 5. So SCF, let's see, SCF of 3, 5. So what is the common in this? The common is only 1. If we do the multiplication, S 3 is equals to 3 into 1. 5 is equals to 5 into 1. The common is 1. Similarly, if we do LCM of 3, 5. So how will you do? You need to find it like this, 3, 5. So you need to calculate this 3, 1, and this is 5. So 5. So 1. So LCM of 3, 5 is nothing but 50. Okay. So that is difference. Now LCM of 2 is nothing but 2. This one, 1. So answer is 2. So period of this particular thing is like this. We need to calculate. Okay. I think well and good. We can go to the problems. Now, the period of a discrete time signal sine 8 pi by 12 n is, what is that? So we need to follow the formula. So period is nothing but d naught. Or here, since it's discrete time, so I'm keeping this n. 2 pi by, this is omega n, I'm keeping 2 pi n, sorry. This is 2 pi n by n naught. This is n naught. This is n. 2 pi n by, this is 8 by 12 by n. This is nothing but 4. 2 pi by 12. This is 4. This is 3, but it is not coming here. 4. 12 by 4 is nothing but 3. So answer is wrong here. It should be 3 somewhere. So I didn't tally with the options, but whatever coming here is 3. Because 12 by 4 is 3. It's not 12. Oh, sorry. Oh, sorry. So since we got is 3. Okay, in discrete time, what we got is 3. Now, since the period of any discrete time signal can be the integer multiplication of 3. So any integer multiplication. Okay, so it can be 3, it can be 6, sorry, 3 into 3, 6, it can be 6, it can be 12, it can be. So any integer multiplication should be the period. 4, 3.
And then all the options are correct.
Yeah, in this all the options are correct. In discrete time period, you don't have, you just keeping n, 3n. 3n is the period. It's not 3. You can just tally with the internet also, but yeah, I'm sure this is 3n. It's not continuous. So if it is continuous, then it should be 3, like this. The answer is 1. But in discrete time signal, you are having all the answers. So I haven't tallied with this option, so answer is all the correct answers. I will give the confirmation next week. Don't worry about this, but we'll give it. But I'm sure it should be all the 4 options. Now, if xt is a rectangular signal equal to unity between minus 15 to 15 and 0 otherwise, what will be the x2t? So since it is a compression, since it is greater than a is greater than 1, so it is a compression. So it is divided by 2. So 15, it is answer is a. How? This mod of t less than equals to 15 is equal to, it seems that t minus 15 to 15. So if it is rectangular, 15 to 15, this is xt. So x of 2t is nothing but the answer is A. So yes, 2 pi n by 2 n by 5. So what will the answer? Tell me. It is aperiodic. Period cannot be irrational. Period cannot be irrational. So here we're calculating n naught. This is pi square it's coming. That is not possible. Pi square n. So it is not possible. So it is aperiodic. Goes linearly with n, does not repeat periodically. It is aperiodic. Okay. We need to calculate. Determine the period of sine 2t, sine 5t. So if we tally with the formula, sine 2t, sine 5t is cos y minus cos x. 1 by 2 cos y minus cos x. Yeah. So the formula for this is sine 2t, sine 5t is equals to 1 by 2 cos y minus x or x minus 5 minus cos x plus y. So 1 by 2 cos obviously t 3t minus cos 7t. So yeah, so this is x1t and this is x2t. So x1t ka t1 is 2 pi by 3. So, and t2 is 2 pi by 7. So t1 by t2 is, let's calculate, t1 by t2 is 2 pi by 3, 7 by 2 pi. So
7 by
it's
3.
rational only. Yes. Now LCM we need to calculate. So LCM of T1, T2 is nothing but LCM of 2 pi, 2 pi, FCF of answer is not much. FCF of V7. 2 pi by 3, the calculation is not correct. I didn't check with the options. There were so many uh, incorrect options were there. But since SCF of 37 is what? It's 1, 2 pi. So answer should be 2 pi somewhere, maybe 2 pi here. So SCF of 37 is 1. It's not 3. If it is 6, definitely it will be 3. But 37 is 1. So 2 pi by 1, it is 2 pi. It's not matching. This particular thing is wrong. Okay. Now, if xt is direct delta function, then xt by phi is what? It's area of delta direct function gets phi times. Okay, how? Because you have this xt. Okay, this is having infinity value, delta t, t. Okay, and you're keeping it as infinity value at t by phi. So t by phi, it will look like this only. But the integration over x delta t is 1. Then integration over delta t by phi dt should be phi. How? Because this is going phi here. So it's expanding. So if you see here somewhere it is expanding 0 by phi and it is giving phi. The answer should be phi times. Because, yeah. So scaling property of direct vector function is delta a t is nothing but 1 by mod a delta t. So we had delta t by phi. So 1 by 1 by phi delta t, and this is phi delta t. So delta t by phi. So we have integration over delta t by phi dt is phi integration over delta t dt, and this is 1. So phi is not. Very good. So next question. Yeah, this is interesting. If sine 2 pi t xt is equals to cos sine 2 pi t and yt is equals to cos 2 pi t, what is the relation between sine t and cos t? Hmm. What is the relation? So if we see the quadrant wise, first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. So in this quadrant, all are positive. Sine, cosine, tan, all the things for constant. And if sine is added to pi by 2, it becomes cos. So I think the answer is D. Sorry, C. So cos, sorry. Since sine and cosine are phase shifted by pi by 2. So let me see with the graph. It is positive or negative, I have doubt. So okay. So this color is cos. This color is sine. So Cos is actually delayed version. So how can we see that? This we need to see from the delayed and cos version. So if we see cos, so whatever one was happening here, it came here. Okay. So this is a delayed version. So yes, answer is C. Because whatever here it was happening, it happened here. So this sign, if you shift it to pi by 2, this is the sign. And if you shift to pi by 2, it will come this. So answer is this. And if it is negative, obviously the answer will be D. Okay. Hmm. Question number 7. So if xt is triangular signal spanning from 0 to 4 and yt is compressed version spanning 0 to 2, then xt and y2 represented as? Gaurav, any idea? It is talking about compress. Okay. As we know, compress always says that A greater than 1. So A greater than 1, where it is coming? Only option X2T. How? Because as we know, X80. If A is greater than 1, then it is compressed. A less than 1, it is expand. And since it is 0 to 4, and you are getting it 0 to 2, so it is a compress only. Nice question. It's very easy. Question number 8. It's very simple. If xt is a rectangular pulse spanning from 0 to 4 and yt shift is to 0 to 2 to 6, what is the relation between xt and yt? So what exactly it's happening? So previously it was 0 to 4. It is getting shifted to
2 to 6.
2 to 6. So this is supposed t. So this is t plus 2. And
Yeah,
that you're doing in the time domain. So actually it is happening as a t minus 2, as I told previously also. Yeah. Huh. So here, if it is x80, I'm doing actually is xt by a. If it is xta, in actually time, we are doing at. If it is minus, it is doing plus, and if it is plus, it is doing minus. Like this, we did. Okay. So,
correct option will be
yes, very nice. So, answer will be B. So, with this trick, you will never ever forget and have confusion. So, since it is moved forward by 2, the right answer is ninth question. So, omega 1, it is talking about this, omega 2 is talking about this. So, we know that omega 1 is not equal to 2 pi by 2 pi t. Sorry, 2 pi. Omega 2 is nothing but 2 pi by. Question is not written properly. And if it's rational, then it is period. This is rational. This ensures that both numbers repeat after some common period. Then it is a correct answer. Last question. So if xt is equals to a sine 2 pi t and yt is equals to b cos 2 pi t, what is the relation between xt and yt? That's good question. Y.5. Y.5 because see cos 2 pi t plus 0.5 is nothing but cos 2 pi t plus pi. Question is again not written properly. Cos pi t 2 pi by 2 it's cos 2 pi t plus pi. It cannot be the case, right? It should point 2 pi or something. So it should be plus only because we saw yt is the advanced version. Okay, phase relationship. This is just is that sine pi 2 and 2 pi t has a phase relationship is b by a t minus 1. So I'm not sure about this question, so I'll repeat this next week. And this question I made it randomly, so it should not be this particular options to tally with the exact questions. Okay, so we will see some of the simulations before ending the class. So I will show you that. So yeah, this finally, if we see the summary first. So this formulas you please take care or remember, it is very, very helpful. So I will upload this slides in the drive folder where you can access it. And you will have several formulas that is very, very important. You should remember. Okay, that's why I have written here. And yes, so these are the questions that we discussed and some key concepts also we discussed. So second week is also very, very, very easy. But from the third week onwards, we will have some more questions and example problems. And I hope this is very much clear to you. And you should also implement this in practice. When the concept of Fourier transform comes in the picture, you will love the signal system with uh, the pace and with the tricks and all those things. So that's not a problem. So two, three things that will I'll come back to you on the third week. And finally, if we see the summary, so we saw discrete time, continuous time. Then we saw what is a digital signal. Then we saw what are types of signal that is just even, odd. Then we saw what is a periodic signal, what are the characteristics of periodic signal, how it looks like, and whenever the picture of periodic signal comes comes, then we saw what is the power and what is the energy signal, and how will we calculate the power of energy signal and energy of power signal, how these are correlated, and what is the inner product. We saw orthogonality through inner product also through the programs and the Python codes also. Then we saw why that inner product is required. Then we saw some of the example problems related to period and non-periodic things. Then we saw some physically arguing signals. And here we are concluding this theory part. So lastly, I'll go through some of the codes. I'll share my screen. This taking time, just a second. Yes. So similar to some of the questions. So let's go through some of the questions. So simulate the question number one, discrete time signal period. So how this looks like. Suppose omega is 8 pi by 12. Okay. And we are keeping sine 8 pi by 12 into n. So how will it look like? So what is the question? Sine 8 pi by 12 into n. So let's see what is the amplitude and signal. Let's see this. So sine 8 pi by 12 into 1 looks like this. And what is the period here? So it will be like 2 pi by 8 pi by 12. Okay. So here it is a 3. So we can see the question was wrong. So suppose this particular thing. This is repeating one, two, three. So time. Okay, so it's not written properly here. It's 0 to 10, but you can see here it should be three. This particular dot and this particular dot is three. It cannot be pi. The whatever it was written. So it is not a correct answer here. So moving to next question. Ah, simulate question two, scaling rectangular signal. So we saw how will the scaling looks like. So suppose we have rectangular signal and how will the scaling of the rectangular signals look like. So scaling we were doing with respect to two. So 15 to 15 was there. So let's see the question solutions. So see, you can see this is the xt and the orange color x2t, and it is from previously from minus 15 to 15. It came from minus 7.5 to 7.5. The scaling effect on rectangle, so it is actually compressing it. Okay, moving to next question. Aperiodic discrete time signal. So aperiodic signal 2n by pi, how it looks like. It was asked, four options were there. So the correct answer was aperiodic. Okay. So what it is this, yeah, that the signals or the symbols or it's not repeating. It's not the same. So it is changing. If it is same repeating, then only it is a periodic. So it is a periodic signal, how it looks like. Suppose this is the symbol and it should be same somewhere after subsequent amount of time. Even it is not same in the negative time domain or the negative amplitude. So this is how we can see the aperiodic signal. Now simulate question four, product of sine 2t and sine 5t. So we saw cos we represented in terms of 1 by 2 cos 3t minus cos 7t, right? So actually how the signal looks like. Let's see. Yes, the product looks like this. And we were asked to calculate the period, I guess. So let's see, this particular signal is repeating at this particular point. So when it is repeating, uh, so it is repeating only. So this is this. So what the difference between these two? Suppose let's say it is 5 and let's say it is 1. So 4 around. Okay. Now simulate approximation of delta function was there. So we saw the area will be increased by 5. So let's see t by 5. And the sixth question is cosine and cosine relationship. And seventh is rectangular signal compression. Eighth is rectangular pulse shifting. Then periodic signal condition. The tenth relation between sine cosines. Some questions are redundant. So let's see quickly. So uh the red color, sorry, orange color is delta t by 5, and from the scaling property is 1 by 5, but at the same time you can see it's the amplitude is increased by 5 in the discrete time. Since it is a discrete time, it is amplitude increased by 5. If it is a continuous time, it will not be. It is the area will be infinite only. Sorry, the value will be infinite. Okay, so that's why it is scaled by 5. So phase relationship between sine and cos. So you can see cos is, yeah, pi by 2. So left is what? Advance. So cos is actually advance version of sine, pi by 2. Left is advance. So that's why. So you can see xt is this one and x2t. So 1 by 2, 1 by 2. So this, since it's a 2, so 1 by 2 is 0.5. It got shifted here. And 3 by 2, 0.1. So it is got shifted here. Now xt is this and xt minus 2. This is minus, so it is going here. So it is shifting to right. So this is what is shifting to right. And it got shifted here. Periodic signal, this is, since it is repeating. So this got repeating here. So this is 4 and this is 6. So we've calculated also the period is 2. You can easily see that. So 6 minus 4 is 2. So all the signal values are repeating at 2. Period is 2. Okay. And the relationship between scaled sine and cos was scaled, yeah, scaled here is 0.5. So it is not in the plus or minus, it is in the actual values. So see, xt is sine 2 pi t and b is cos 2 pi t. Okay, this is scaled version. Fine. So yeah, so I have uploaded this code also in the drive folder. You can just check it there. And so I think enough for today. So if you have any doubt, you can just let me know. You can reach me out to my email ID or my YouTube channel where I'm uploading these videos. And whatever doubt is there, we can just discuss there. And if possible, please fill the feedback form. Okay. Thank you so much, Gaurav, for joining.
Okay,
Uh,
thank
it- yeah, we will end the class.